We launched into SPSS, by God's grace, 2 days ago. And then we discussed on how and what SPSS is all about. I'll just go through again, very snappy. And this will just be like a reminder. And then we move from there very fast. Okay. On my screen, as you can see, is the SPSS environment. And there is a data set there that we'll be working with tonight. Okay, so I told you about SPSS, that SPSS is one of the oldest statistical application, one of the oldest that helps in all statistical calculations as it entails in data analysis, right? SPSS itself means, what do they call it? Statistical program. I'm correct. Okay, statistical package for social science. It was called that initially, but now it's called statistical products. It's called statistical products and services solution. Initially, it was called statistical package for social science. But now it is called statistical product for statistical product service solution. Okay, so what it helps is that everything about statistics, the formulas, everything about it, calculations, they are already in SPSS. You find them richly in SPSS. You can easily say that SPSS is the baba of all statistical formulas as regards that. Right, so SPSS it still maintains those old previews of having, if you have worked with Access before, you know that Access and SPSS has those old pattern of arrangement of data before being analyzed. So SPSS has two windows. The first is the data view window. This data view, which is actually the spreadsheet of SPSS. And then we have the variable view, which I term it as the kitchen of cleaning or cleanup for the data itself. You come here to set up your cleanup, your data, how you want it to be, and then you come to the data view and commence your analysis. Variable view is that setting, is the room whereby you set up your data, you clean them up in accordance to how the data should appear, right? To the extent of the names of all the columns, as you will see here, are being edited under variable view, not even in data view, right? The names are edited. If you want to edit the name, assuming you're on data view, and you want to change education here to something else, even though you double click, tap, it will take you to variable view for you to do those corrections, right? So variable view is where you do the corrections of the data type with decimals and all that. And I took my time that day. We went through all of this. That name is synonymous to the column name, right? Name there. If you can see name, don't know if my screen is large enough. The first column there, if you can see my mouse, is name. And then the name there refers to the name that will be appearing on the column in the real data set. So all these ID, age, gender, education, employment, income, all of them will appear on the columns. They become the column heads. Heads when the data is being, imported or, type into the data view angle. So we have the type. So this type refers to what kind of data will be used in each of these columns. Now, if you look at ID, it's numeric. So that means you'll be using numbers. in this column. Age should have been text. Now let me just show you some types of data that they have. We have numeric data. Apart from all this, we have date and time. We have string. So string refers to text or letters, anyhow you want to put it. Numeric refers to numbers, and of course date and time refers to date, as the case may be. So what kind of data do you want this column to carry all through? Because it won't carry any other thing. If we set numbers here, if you type any text there, it will shout. So you need to set up the data for each of these columns before you commence, and you do this setup under variable view. So the width here is how many characters. How many characters? I don't want to use letters, but if it is in text, I will say how many letters. If your name is Victor, Victor is 5 letters. So you need to put 5 letters there, or 5 width there. But if you know that you want to make it Victor Jeremiah, which is first and last name, you need to count the characters and write there 50. Because if it is only 5, it will only carry 5 characters. It will not carry more than 5. So if you know that you are doing first and last name, assuming we have name under this column, then it will just articulate immediately name, and then it will carry you just put 50 or maybe 60 characters under the width. So that you carry all kind of names, as the case may be. Now we have decimal places. Will your column carries decimal place? You need to answer that. If it's yes, then you put decimal place. Like this rate will require decimal place, just one decimal place. Then you need to introduce decimal place. If you don't introduce decimal place and you want to put decimal points, it will round it up to full number. So it won't. The statistics here is really strict. It is guidelines. Okay, so label here is expanding the column name. If I want to use that word for now, like this ID that is here, you can express it here and write identity here, right? So you can easily expand, assuming you wrote anything in short form, you can write in full form here under label. Assuming you wrote anything in short form, you can write it in full form under label. All right. Okay, so I just remember something, that under this name, this first column, you don't need to keep any space. You have two syllabic word to use, like first name. First name is 2 syllabic word, right? And then you want to write first and give a space before you write name, or you want to write last and give a space and write name. That space you want to keep there should be replaced by underscore. But you can keep a space under label when you are writing the first name. Under label, you can write anyhow you want to write, but under this name, there is no space in between. That's why there's an underscore in between 2 syllabic word there. Okay, so we talked about values. Values here refers to, is actually required when you want to make use of a text information, the information in textual form. You want to make use of it in calculation. We can't text, let me say alphabet times 1 will give an error. If you are following very well, alphabet, any 8 times 1 will give an error when it comes to statistics. But you actually want to make use of those texts to still do your calculation and bring out results. So statistics here, or SPSS here, came out with an understanding whereby you can change those textual examples or data into numbers, right? Just like what we have here. Under gender is male and female. But as you can see, gender here is set to 1, female is set to 2. Let me open it so that you can see. Gender is set to 1, male is set to 1, female is set to 2. And then that automatically makes gender to be numeric. Gender shouldn't have been numeric on that data type. It should have been text or something else. But now, since we have changed the text to numbers, then we can now keep it in numeric. And now, because it is numeric, you can use it to do any calculation you want, any multiplication you want to multiply, any statistical whatsoever, and it will give you the accurate answer, right? So that is what is meant by values. Values means to replace text with numbers, right? You replace text with numbers so that you can use those texts or those understanding to find out the information you are looking for. Now, missing, would there be any missing value? No. That means if there's any missing value, it will draw your attention. So this is column. There's no issue about it. This column width, there's no challenge about that. So alignment, all know alignment. Alignment is to keep your information, coordinated. Like align to the right, to your margin, or to the left. Anyhow you want to align your information, whether to the right, to the left, or to the center, you can align it as you wish. Okay, so and then measure is the next understanding I want to point out. Now, anything that is numeric naturally, like serial number, which is numeric naturally, we keep it at scale. We use scale as the measure. Anything that is numeric or that is number, like loan amount, savings, income, all these are numbers. So you keep all numbers under scale. You keep all numbers. You choose the measure is scale. Now we have other two are ordinal and nominal. Now ordinal means text data that is in hierarchy. Any text that is in hierarchy, that means those texts are in order of so and so. Right? Okay, let me give you an example. Order of let's say low, medium, and high. If I are those are in hierarchy, so those information are being categorized under ordinal. Yeah, yes. So they are being categorized under the word ordinal. So any information that carries such information, you keep it at ordinal. And then nominal is normal SMS or text. Sorry, I said SMS. Nominal refers to the normal text, text and anything that is, any text that is not in order, in hierarchy form, you keep it at nominal. It's like the opposite of ordinal. Now, like this, let me show you an example. Yes and no. Yes or no are not in hierarchy. It is either yes or no, or it's either no or yes. So that is nominal. Now, male and female, they are not in hierarchy. It's either male or female. So those are nominals. And then general text, nominal can flow through as well. Any general text, you use nominal to run through it. All right. If you understand to this point, can I hear a reply? Do you understand me to this point? Stella, are you there?
What about?
Yes.
Okay, Stella has gone out. Okay. So row here is to, take dependent and independent data on your data set. Yes, you need to set, if you wish to, you need to set what is dependent and what is independent on your data set. And assuming, let's say, lack of eating causes ulcer. Now, eating also depend on lack of eating. So that means also is a dependent, and then lack of eating is independent, kind of. So you need to set all those dependent variables, but it's not actually an issue whether you set it or not. You do the actual calculation when it comes to the real formula. It's not the setting here that will determine the end product. Okay. So, but the input here is just, it represents independent variables as it is. Why target depends are the dependent variables. Okay, now as I've said this before, we have two views. When once you have set up your information like this, then you just come to your data view and then you start typing your data or you import your data. Once you import your data, come over to variable view and set up the requirements. When once everything is okay by you, you come to your data view and start your analysis. Right? So these are the processes and procedures as regards to the onboarding into SPSS. Okay, so we did few calculations yesterday, so we'll just be touching on them one after the other by God's grace. We'll see how we can run all through the calculation. One thing is that we shouldn't be afraid of any application. Don't need to be afraid whether you have seen it before or not. You need to remove the fear, and then you follow the steps and you will get the same results that we have even right here. Okay, let's commence now. Now, if you look at this data set, the data set is from a financial company, like a microfinance company. And then they are looking at the behavior of their customers and then the characteristics of them themselves, their values, and the customers, as well as the loan performance, right? So the data set here tells us the customer they have, the loan performance of the month, and then customer record, and then payment of loans, etc., even down to rates, right? So with this now, we have some few questions to determine the answers, right? And one of it is financial profile of the customer. What is the financial record of customer A, customer B, customer C? What is his record? That is number one. Number two is there any difference in income between the employed customer and the self-employed customers? Is there any difference in their income? How are they doing personally? How are they doing? Is there any difference between their income? And then number three is credit score associated with loan payment? Normally, it should. Credit score should be associated with loan payment. Credit score here refers to how the customer respond by paying back his loan. That is what is meant by credit score. So when the customer pays his loan on time or as at when due, he has more credit score. So credit score actually is associated with loan payment, even though we have not even started, but that is the meaning. And then we are looking at, does debt to income ratio affect loan default? Debt to income, does it affect loan default? Default are people that don't pay their loan on time. they don't do their repayment on time, right? So, but we'll get to those things one after the other. There are other questions. Another question here is, does educational level of our customers, does it affect their savings? Those are information we need to figure out. And then, what factor predict loan amount? What are the factors that will predict loan amount? We can get that, we'll get that. Then the next question we could ask is, can a customer's financial characteristics be used to predict high risks? Can a customer finances be used to predict high risks? These are few informations that we will need to derive on this platform this evening. Okay, so for a very quick understanding, a very quick notification before we dive into our analysis, we have gender to be male and female, and then educational level we have secondary school certificate customers, we have diploma customers, we have bachelor, we have masters and PhD customers, and then under employment we have those who are employed and those who are self-employed, even down to unemployed. And then under repayment status, we have the defaulted customers, meaning those that don't pay their loan as at when due. And then we now have repaid customers, those who pay their loan as at when due or normally. And then we have the risks associated with it. Well, it's been categorized under low, medium, and high rates. So these are a few information about this data I want you to have at the back of your mind, so that as you are doing the analysis, you will understand the result as well. All right. There are some few notifications I want you to understand when it comes to statistics. Statistics, we have what is called probability, right? We have what is called the hypothesis. We have what we call non-hypothesis. We have alternate hypothesis, and all these terminologies. We have some few like mean, median, mode, etc. So we have significant figure which will determine whether we should reject or we should accept. It will also give us the information required. We have correlation, we have regression. All these are few understanding that you need to have at the back of your mind, even as we run through this analysis. Okay, so at this point, let's commence the very first analysis now. Right, well, we'll start afresh from the beginning and we'll see how we could drive down to conclusion. Okay, please, the admin has dropped a message. Please, everyone should kindly respond. Just take a minute, respond to admin. Please, everybody should kindly respond to the message admin has dropped. And then, if you have any question during the class, please kindly drop it. Just call my attention, and then we'll see how to figure those answers out before we continue in earnest. All right. On your phone, I just want to bring this to your notice. On your phone, you can drag out or zoom up, zoom out, so that you can see the screen very well, and then you follow suit with the class. Please, these are few tips so that you will not be left behind. Zoom into your phone so that you could see my screen very well. All right. One of the menus that you'll be really conversant with in SPSS is called analyze menu. Analyze menu, this menu here. Analyze, right? And then after analyze menu, you work more as well with graph menu, right? Analyze carry all the analysis it can, apart from others that are not under it. But we have most of it under analyze menu. All right. The first step is always when your data is okay, you don't need to select nothing. You just go straight to analyze, and then a lot of analysis techniques are being listed out. If you have your time, I really want to go through them one after the other to see what they can give under statistics, right? Okay, but today let's start with the most simple one, the simplest. Just pick something very simple, and then we'll grow from there step by step until we finish. Okay, now under analyze, there's what is called descriptive statistics. Descriptive statistics. And then if you hover over it, it will bring its own drop down. And then the first drop down there is frequencies. Let's just click on frequencies. All right, so frequency dialog box is open. And then I want us to just do one or two to know the frequency of each data set that is being listed out there. So let's pick gender. Just pick and drop. Either you drag and drop, or you select and click into the variable box there. Let's pick gender. Let's pick education. Let's pick employment. All right. Let's pick repayment status. All right. Let's look at default rates involved. And then at this point, let us just click OK. Right. Now, frequency here refers to the total count of those variables we have chosen. It will just go in and find their total count, then drop the information there for us and tell us, oh, as you can see now, it's telling us that age is, we have 20 data sets, 20 rows in this data set, and then it went through to spell them out according to the data variables that have been chosen, which is age, telling us that we have people of that is up to 25 years old down to 55 years old person. All right, that is for age. If you scroll down, educational level says that we have 4 diploma, 9 bachelor degree holder, we have 5 masters, and then we have 2 PhD, right? Then if you scroll down, employment status, we have 14 persons who are actually employed, and then we have 6 persons that are self-employed. 6 persons are self-employed, right? Please, can you see my screen?
Very well.
Thank you very much. Okay. And then, as you can see from my screen as well, we have a repayment status. We have repayment status there. And then we have 7 persons that have already defaulted already. 7 persons are categorized under defaulted, and then 30 persons has paid their money. All right. So we have seen some information about that. Then we now have the risks involved. That we have 9 low risk persons. And that calls for questioning. We have here those that have paid their loan at 13, but is it not the whole 13 that should have been under low risk? Why are we now having 9? Right? We should have the whole of 13 to be here, but we are having 9. That means there are some information that we need to dig out from the data set to know how it's being categorized under low, medium, and then high. So already under the default persons, we still have 1 person that left it, and then we have 6 persons that is high. Okay, but this just to tell us the total number of information, total number of each variable, indices that are found in its data sets. So this window you are seeing me move up and down is the output window, while the data set window is our data window. Okay, so at this point now, let's continue our analysis. I can see Mr. Joseph has joined us. You're welcome, Mr. Joseph. Okay, so our analysis, let's continue. Let's look at the next function here, which is called descriptive. Very simple. Analyze menu, descriptive statistics, then you click on descriptive. Analyze menu, descriptive statistics, then you click on descriptive. All right, so under this, we want to move age, income. Have in mind, age now is now a numeric indices, right? Age, let's move income into the variable box. Let's move expenses, monthly expenses, into the variable box. Let's look at the savings, right? Let's look at credit score. Let's look at credit score there. And then the loan amount that is being given to each customer, let's just preview it. And what is the interest rate when anybody, the interest rate or the percentage of interest given to the customer? What is the interest rate? And then the very last, let us look at the ratio. Debt to income. The ratio, what is the ratio of debt collected to the income gotten? Just move it there. You can select it, and then you click this arrow, it will be taken straight into the variable box. And then if you click on options, there's options here. A lot of central tendency are reflected already. Central measure tendency, we have them there, which are the mean. We have the standard deviation. We have variance. There's range. There's a skewness, and then kurtosis, of which we saw these two when we were doing data analysis in Excel. We saw this few information there, right? So just activate mean, standard deviation, minimum and maximum, and then you can keep your ascending means if you want to, or you keep it on the variable list. There's no issue there. Click on your continue, and then come here to click on OK. Now, on my output box or output window, you agree with me that the descriptive table has appeared. Our descriptive table is here. Now, on the table, it has taken all our column heading or indices or data into the central tendency, calculation that we just received or we are trying to find, and then did it work? Now, what am I trying to say? The N is the total number of the data set, individual data set or data we have. And then the minimum, what is the minimum value of age is 25. The minimum person, the youngest person is 25 years old. And now the eldest person, which is under maximum, is 55 years old. The eldest person is 55 years old. And then the mean age of all the data that is there is 38.45. Okay. And then the standard deviation is 9.029. Now, I will employ you any of these terminologies that you don't understand. I can give you a few understanding, but I want you to go and find more so that you can, solidify your knowledge on each of these terminologies. Now, standard deviation simply means the distance between the average distance between a data set from its mean, right? It has a formula that can give you all this information that it will allow. Now, looking at monthly income, the minimum person under monthly income receives 240,000. The minimum person. And then the maximum amount person under monthly income is 700,000, right? And then the mean is 400. The standard deviation is 131. Okay, monthly expenses. All right, we have the minimum from the expenses recorded is 170. The maximum expenses is 380, and then the mean follows suit. We have savings 20,000 and 180. We have credit score 560, and the maximum credit score is 810. We have the loan amount. So they have given someone the minimum loan that they have given out is 700,000, and then the maximum loan they have given out is 2 million. Okay, for a month. I don't know why they decided to give somebody a loan of 700,000, whereas the minimum income of the person is 240,000. How would they expect the person to pay 700,000 in a month? Nevertheless, they may have given him or her not just to pay in 1 month. Maybe they have expanded the loan term. So there is a data set. There's an indices called loan term. The time to pay back your loan might be 3 months, 6 months, and all that. So these are information you need to get so that you could verify as you discover any indices or insights from your data. So we have the interest rate. So we have the minimum interest rate of 10.8, and we have the maximum of 21.5. Okay, so we have debt to income ratio. We have 13, which is the minimum, and then we have 62, and so forth, and so on. Okay, we have gotten this few understanding. Let's go deep. Let's go deep now. Still on this output window, you can still find analyze, as the case may be, but sometimes I do come back. You can stay here to do whatever I want to do with analyze. It's the same analyze and everything will show, right? But sometimes I do show you the two windows so that you not be afraid and all that. You must understand that two windows displays simultaneously. All right, we have graph. Let us plot one graph. Let's see how this works. Let's get a graph. Click on graph, then click on chart builder, and then under these samples, choose histogram, then drag simple histogram into the preview space, and then pick up monthly income, keep it on y-axis, right? Then drag educational level, the level of education, and keep it on x-axis. And then still drag gender, drop it on filter. Right? Gender on filter. Let me change the color. Chart appearance. Okay, let me choose this. Let me choose this multiple. Education to X, monthly income to Y, gender to filter. All right. So at this point, let's pick, I'm looking for a good color. Okay. Male, then female. Beautiful. All right. Now, as you can see now, we have gotten some information about the income, the educational level, and then the gender. As you can see with me, let's leave it like that. There are some other things if you feel like to activate, we have grid lines, and then let me set this color. Beautiful. So we have grid lines. If you want to activate them, you can click on them and it will come to play. Or the same, if you don't want it, you can deactivate them. But let's click on this first. Okay, so with this, we can just click on OK if you're okay with that presentation, and then our graph will just appear. Now the graph is showing us the monthly income, the educational level per person, and then splitting them into male and female. Now it is understood that PhD earns more than even the secondary school, which is normal as the case may be. But this is how to create a graph, a very simple one at that. Let's go to analyze again. Let's continue still on descriptive statistics. And let's look at the third analysis there, which is called explore. Explore, right? Explore here, we want to drag income, monthly income into dependent list. And then let's see what does employment affect or contribute to income, which is very simple. Drag employment status to a factor list. I feel like dragging educational level, of which we have seen it already. I feel like dragging that here, but let's get it running. Now you can actually do your statistics, but we'll just keep it at a descriptive by clicking on statistics. Then we just keep it at descriptive, and then but let's look at some plots. Keep the plot on normality histogram. Click normality, and then click on continue, and click on OK. All right. If you can see my screen very well, You agree with me that employment have just two set of persons under it, which are the employed, we might be government workers, and then self-employed business people. 14 and 6, making a total of 20, right? And now coming to income of the statistics or descriptive information, we have the 95% interval. The lower bound is 366,283. 95%. Have in mind we saw the minimum value and the maximum value initially. This is also of such understanding, right? We have the trim mean. You see the mean, the median. We have it here. The variance is here. Standard deviation that we saw is still this value. Beautiful. Minimum, maximum, range, interquartile, skewness, and curtices. They are all here. Now, this only for the employed. Now, the same information for the self-employed. Self-employed, they mark the minimum, the mean of their income is 333,000, right? Compared to the mean of, in fact, let's use maximum so that you can understand. The employed people or customers earn 700,000 naira a month. But the business people, they make 558,000 naira. The apex, the maximum amount they make, or the maximum, yes, is 580,000 naira a month. So there is a difference in how much they make in a month, right? We have the quartile variance, standard deviation, skewness, as the case may be. Now let's come down to normality. As you can see, the statistical, I want someone to check the full meaning of DF. Can someone help me to check? Degree of, please, Joseph, help me check the full meaning of DF.
Is it not difference?
Degree of something. And then we have significant figure, probably the significance. Significance, we have a degree of significance, which is also here. Stella, are you there?
DF is degree of freedom.
Degree of freedom. Check the meaning so that you can know. Check the meaning, check the application. What does it mean by degree of freedom for the employed?
It represents the number of independent values used to calculate test statistic.
Beautiful. Now check the degree for the probability, the significant value of that is a determinant factor. What is the value that determines the significance of a thing to be accepted? Just type it there. The significance value. So we could use that to compare with what we have here.
Sorry, take that again. I should check for what?
Probability of significance, the significant difference. The p-value of any given analysis.
The p-value of any given analysis.
Yes. Check the value itself. What is the value? Fatima, are you there?
Yes.
I want you to understand. Okay. Also check the value of the probability of significance.
The p-value probability value is a number measuring the chance that your data results happen by random luck, assuming there is no real effects or difference. The null hypothesis.
Did they show you the p-value?
It is always a number between 0 and 1.
Okay, 0 and 1. They didn't give you the actual number itself.
Or researchers often set a cutoff line called alpha, usually at 0.05 or 5%.
Beautiful. That's the value. 0.05. That is the value. Now, if you look at the significant figure here, under employed, we have this point. There's a 0 there. There's a point there. Don't know if you can zoom this. I can't. I don't know how I could zoom this. Okay. Let me see if I can zoom this. This is how I want to zoom this. But nevertheless, if you can see my screen, I believe you still get what I'm trying to pass across. There's a point before 200. There's a point there before 200. So that means is 0.200, 0.200, which is far greater than 0.05. Now, the understanding is that when once the p-value is greater than 0.05, there is no significant difference. There is no significant difference. Meaning that there is no significant difference between employed and unemployed if it is greater than that. And then if it is less than that, if the p-value is less than 0.05, there is a significant difference. Even with this Shapiro-Wilk p-value, as you can see, we have 0.328, and then we have 0.23. The two values are bigger than 0.05. And these are the decision rules, or the striking decision that will make you to accept a null or you reject a null. You reject any the rule that will make you to accept anything or you reject anything is based on these facts that is here. Now we have our histogram normally that shows the frequency of in monthly income for the employed, and then we have that of self-employed, right? So that of self-employed, if you can see here, there is a gap between 350,000 and almost 580,000 here to 600,000 in a month, right? So that means most people, you're right, are under this category. So most of the people that are self-employed only earn 350,000 at most. And then it's like one or two or few persons earn above 500,000 naira. All right. Now, the monthly income using stem and leaf plots has been displayed, as you can see. And then we even have the normal QQ plot, expected normal, and then observed normal. So these are different plots that the statistics or SPSS can come up with that you can use to predict informations as they pop up. But nevertheless, we'll see more plots apart from this. Now, this is called box plot. The ones you saw as scatter plot. This is a box plot. It helps to show us the apex, which is called the maximum, the lowest, which is called the minimum, And then the median, this blue box, the thick line there is the mean. And then anyone that is not even inside a line is called an outlier. 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 O-U-T-L-I-E-R. Outlier. Now, just like we saw, we have an outlier here. We have an outlier here in the under the self-employed. Maybe just like one person, just as is being displayed here. One person is now earning above 500 to 600,000 naira. So this a box plot. We may see more of this box plot in here. We can find it in when we get into Jupyter Notebook, and I hope there's a box plot in Tableau at least. Okay, so we have some educational level kind of, we needed to preview that as well. Now the descriptive values for the education, which is the diploma persons, has given us what we need to see, which is the minimum value for a diploma person was 260,000. The maximum is this, and then the skewness is this as well. And then it now breaks down for us in accordance to the descriptive understanding. But however, the test for normality is as follows: the statistics here and the degree of freedom for bachelor is high compared to any of them, right? And then the significant value is still high, 0.200. Now, if you look at this star, they say that this is a lower bound of the true significance. And then we have the Lilliefors significance correction, as well as the Shaparo-Wilk significance detection here, as you can see. So these are the information that we can fish out just by doing exploring, statistics that we just accepted to preview this information. A lot of them are here. Beautiful. Okay, let's run. Let's go further. Let's look at cross tabulation. Now, under cross tabulation, he wants to take a question known as, is repayment status associated with gender? We want to check who and who. Do the female repay their loan, right, than the male, or does the male repay their loan than the female, or is there any relationship at all? If there is, then we'll know, and then we can dig deep to know why, and then we get those information done. Very simple. Let's go to analyze descriptive, come to cross tab, and then immediately just take gender to rows, pick your gender and drop it on rows, and then pick up your debt status to columns. Repayment status to columns. And then under statistics, just activate chi-square, or someone will call chi-square. Then cell row, activate that as well. I may even like to activate contingency coefficient and even correlation for now. Okay, Just click continue here. Come to cells and then activate the row percentage. Just click on that. We should use, yes, the observe should be there. We'll just leave that to be there. The easy test will come to that very soon. Very soon. And then just continue. And then let's look at, let me see if there's one or two things we can do here. Okay, this is okay by me. Then click on OK. Have in mind, we were looking at the repairment between male and female. The repairment between male and female. And then we understand that if the percentage significance is greater than 0.05, then there is no significance at all. There's no relationship at all. But if it is less than 0.05, then there is a relationship. The two things we were trying to discover can actually affect each other, right? Okay, now look at this chi-square. Let's start with the gender first. Or this just the count and the total. Okay, there's nothing much here. It's telling us 7 and 13. There's no big detail. Now the chi-square here, degree of freedom is 1 normally, and then the significance for the two-sided is 0.350. 0.350, as you can see here. Even the asymptotic significance is 0.16. The exact significance is 0.17. This simply means that there is no relationship between gender and payment. Being a male does not mean that you will pay us as at when due, or being a female means that you pay us. It doesn't mean that way. It doesn't mean. So this is the interpretation of this term. Now, even down to symmetric measures, the contingency coefficient is still higher than 0.05. It's now saying not assuming the null hypothesis. And then we have here using the asymptotic standard error, assuming the null hypothesis based on normal approximation. Yet it is not up to approximation here is 0.16. It's still higher than 0.05. So we can't buy that understanding. We can't buy the understanding. Let's still go back to chi-square again. Let's have something to do. Analyze. All right. It's by chi-square. Okay. Okay, analyze. Compare means come to analyze, go to compare means, and then choose independent t-tests. independent t-tests. Now, we want to see average income. Does it differ between customer that pays back their loan and those that doesn't pay? Average income, does it differ from those that pays their loan and those that doesn't pay? Very simple. Once you are there, pick up income, monthly income, drag it, keep it on the test, and then drag repayment status into groups. Define the group, yes, and then click on continue. After defining the group, click on OK. Let me check this option first. Okay, 95, correct. Now, click on OK. There's a one in here. The independent samples effects size table is not produced. Okay. So it cannot be computed because at least one of the groups is empty. Let me check which group is that. Let me check my data set. Under repay loan, let's check. Okay, I'll be seeing we use 0 to represent default. So let's change the data set. Let's change the data set. Just double click. It will drag us to where we can change it immediately. Now let's change the values to 1 and 2. You also click on default, change default to 1. And then click on change, you say okay. Then change repay to 2 so that everybody will have their information there. Click on OK. Let's go back to our output view. Analyze, compare means, independent, define the group again. Everything is okay. Click on OK. It's still showing that error. Okay. Let's use ANOVA since it's not giving me what I'm looking for. Let's go to ANOVA, one-way ANOVA, and then we will hit straight at there and we'll get what we're looking for. Very simple. Analyze. Come down to Bayesian statistics and then scroll down to one-way ANOVA. Okay. So at this point, does monthly income differs from those that pays their loan? So very simple. Take dependent value to monthly income, right? And then take repayment status to factors. Very simple there.
Sorry, I'm not seeing your screen again.
Okay. Have you zoomed your phones? Have you zoomed in on your phone?
I've been following you, but suddenly your screen went off.
Like you can't see my screen?
Yes, I cannot see what you're doing. I'm just hearing you.
But me, I can see my screen. Joseph, can you see my screen?
Yes, sir, but it's a bit tiny.
Zoom your phone out as if you are increasing the size of the picture. Just zoom out on your phone. You'll be able to see it clearly. Fatima, can you refresh again and come back? Because me, I'm zooming, I have a control so that I will be seeing what you people are seeing. And then I can
I've
zoom
done
in on my phone. Okay. I can zoom in on my phone and then I make sure that everybody's on my page.
It's okay now.
Okay. Income into dependent variable. And then we can even pick two. Let's see if we can carry two things. Here is education. Let's pick in education as well. Okay, only carries one. Okay. And then let's look at the criteria here. 95%, correct. Bayes factor, no, it's okay. Let's look at plots. Just plot the two for us. Continue. Okay, so Bayesian estimate has given us a plot, and then you have in mind we're thinking, well, looking at does monthly income affect or has any significance with the does monthly income have any significance with repayment? Hope you are following me now. Does it have any significance? And then we are looking at Bayesian estimate of error variances. Does it have? And it looks like those with high income pays their loan compared with those with low income. But we can't just agree like that. Let's look at the significant value under the analysis here. $1.519 exponential 10. 1.519. If you have your calculator, type 1.519 exponential 10. With that, we want to confirm if the probability of significance is less than 0.05. If that is done, then our answer is right, that those that have high income pays their loan as at when due. But as you are checking that, let's still look at the compare means using, instead of using Bayesian, let's use Bayesian one way. Let's use the normal one way we have here, which we just put in income, monthly income, and then we look at educational level into factors. Have in mind, monthly income can also take credit score You can also take, okay, let me leave repayment for now. Very simple, post hoc, just activate it. Activate post hoc. On post hoc, just click on 2 key. 2 key is what I was looking for since. Keep it there on 2 key. And then let's look at options. Activate your homogeneity of variance, and then you can still look via descriptive and mean plots. Keep it at 0.95 confidence intervals. Click on continue and hit your OK. This is our normal descriptive analysis there. Now, if you look at it very well, monthly income significance is 0.23. Credit score is 0.16. Coming back to ANOVA, we have significant figure of 0.01. Now, at this point, we can agree that monthly income affects, or there is a significant value as regards monthly income and educational level, because they will have a significant value of 0.01. There's a significant value of 0.01, which is less than our 0.05. The same thing regarding a credit score, 0.01, less than 0.01. Even the degree of freedom are there. Now, you can agree with me at this point. You can now agree that monthly income determines credit score, as well as is a determinant factor to educational levels. Right? And now these are the multiple comparison. We have all of them here, as well as their significant value. So once you find out that the significant value is less than 0.05, then that very entity is to be accepted, right? There's a homogeneous subset here, as you can see, that takes the individual educational level. It takes the individual educational level and splits them out at the 0.05 acceptance level of a factor. And then we now have the correlation, as you can see with me. For sure, actually, we have their map being on a straight line, which is a linear map. The mean plot is here. The mean credit score is here. And then these are key information for acceptability that these two indices can run on a very smooth agreement. Very easily, let's analyze for correlation analysis. Very simple. Analyze, come down to correlate, and choose bivariate. Bivariate means two. Bivariate, just choose bivariate here. And then when you hear the word correlation, correlation simply means in regards to the two indices you are looking at, does these two indices relate? Is there any relationship between these two indices? That is a question correlation is asking, meaning that if you want to be an example, does age equate knowledge? Does it mean that the more you advance in age, the more knowledge you have? If yes, that means you guys are correlated. If no, that means you are still correlated, because there are two things. There is positive correlation and then there is negative correlation. But if there is no positive and negative, that means you people are not correlated at all. Right? That means you are not correlated in any form.
That's if the result is 0.
If the result is 0. So the result should be positive, which is 1. Or the result should be negative, which is minus 1, or very close to minus 1. But when it is 0, then the correlation there is weak. Correlation is weak. All right. So let's look at now. To me, I like using something different from what we even have here, because we want to see credit score, income, saving, debt, loan, and then we bring the two-tail Pearson correlation for it to determine for us, right? And then we will find both the ratio and the probability level as it is. So let's push that into that. I feel like bringing in gender as well, but let's leave gender for now. Push in income, push the income into it, push savings into it, take the debt as well, consider credit score, allow loan amounts to join you. If you can, take debt to income ratio to be part of the team. And then it's already activated on Pearson correlation coefficient. Let's keep that. We'll come back for Spearman so you can see the information that could be gotten from this data set on real time. Now, let's look at the test. We are looking at a two-tail test. We'll consider two-tail test. And then let me check if there's any other thing I can. Okay, mean and standard deviation. We have gotten those informations. I may wish to leave it for now. We have been seeing mean and standard deviation. A confidence interval is always our 95. So there's no challenge there. Let it still be there. And then at this point, you can just click on OK. Beautiful. So this is our correlation table. I said yesterday that assuming we are in a Jupyter notebook, this table will be colored. That the coloration alone will make you, see things for yourself, even without looking for the values. Or however, we will still go through the values. To correlate between self is 1. Month income correlating by itself will give us 1. And that is why you have 1. Anything correlating itself will have 1. That's why you have 1, 1, 1, 1, 1 all through. That means at that 1, the correlation was between self, between the same variable. Now, we are looking at what is closer to 1 and what is extreme to -1. You agree with me that monthly income has a positive correlative power to savings. Savings is almost closer to 1. Right? And then we have the mid here. We have minus 0.155. Minus 0.155 under debt. And then we have minus 3.24 under debt to income ratio. Now, the significant two-tail significant figure here is showing us that savings is less than 0.001, meaning that it has a positive correlation to monthly income. It has positive correlation to monthly income. This, right? And then if you want to look at savings, saving itself, even with monthly income, they will correlate on the same value. As you can see, savings is the second indices here. It will correlate the same value as it were on its own counterpart initially. Now, debt to itself is 1, and then debt correlates comfortably with credit score. There's a positive correlation there. Debt amount correlates comfortably with loan amount. You also did same with debt to income ratio, right? So you find out that these are positive correlation, and they are very strong correlation, factors that determine such understanding, as it were. Now, the same thing will reoccur in every of their space and their correlating factor display. Right. So let's check Spearman. This is a Spearman person. Sorry. Let's look at Spearman, still on bifarate or bifarate. You can choose the 2 as well, but let me deactivate. You have this one already. Let's go. Now this Spearman row correlation table regarding those our factors that we have. Now the same thing, monthly income is giving us a very strong correlation factor with savings. Normally, savings, the same thing, will return favor to monthly income. And then debt also is giving a very strong correlating factor with credit score, and not more strong as it were in Spearman, but is strong as you can see in debt to income ratio. Right? Loan amount, coming to the significant figure here, loan amount has no real strong correlation factor to what we are actually looking for. Now, as you can see, correlation is significant at the 0.01 level. Any place you have the 2 stars is telling us the 2 stars here, the correlation is significant at the 0.01 level. And then correlation here at 1 star, they say it is significant at 0.05 level. Right? So the significance is what we are now looking at. So with this, you can now boldly say that monthly income affects or has a relationship with savings. meaning that the increase in monthly income, the increase in monthly saving. But we need to draw your attention when it comes to correlation, that correlation does not cause the effect of the other counterpart. What am I trying to say? Monthly income is not a causative effect to savings, though they correlate. It's just that it can fish out the relationship, but it's not the causative factor to make it happen that way. Right? Let's see one or two analysis. Again, we're looking at multiple linear regression. Okay, this regression, multiple linear regression. What factor predicts loan amount? What factor could be used to predict loan amount? Will you use the salary of the person to predict loan amount? Or will you use salary and the repayment status of the person to predict the amount you need to give out? And you need to check, after somebody has been doing, yes, he has a very good credit score, and you keep on increasing his loan, and he's targeting you until when you now give him the apex amount. What is the risks involved? Before, what are the risks so that you will not be duped, right? Because the person has a good credit record, you now carry your 10 billion naira and give it to him without no collateral or a risk involved was not taken into consideration.
Level of risk.
Yes. So find the relationship between dependent output and independent input. Right. So we'll look at analyze, regression, and then we pick linear. Analyze, regression, then we just go straight to linear regression. Let's see what loan amount can give us. Drag loan amount to dependent value. Loan amount, just drag it there. Click and drag to dependent.
Economic and statistic terminologies.
Yes. And then pick up income, savings score, interest, loan term, and DTI. Drag all of them into independent box here. Just income, switch it there. Debt, take it there. Savings, credit score, interest rate, and then loan term. If you can still put you can put DTI. Very simple. If all is okay by us, come to statistics. Make sure your estimate is checked. Check your estimate, and then agree with model of best fit. Let your confidence value be checked as well, so that you keep us on our 95% confidence value. And then if you can also activate collinearity diagnostics, it will really help in this analysis. And then come to plot. After this, just click on OK, click on continue, then come to plot. Now there is residual. There's what is called residual. Residual are errors. Residual means errors, right? The error that may likely happen without us knowing. And then we have the residual, which is the error, is equals to actuals minus predictions. So any error that could be found when we are doing this analysis, we want to also harness them. We want to harness them. Error under this analysis, so that it will not give, or will not be running on an error, statistical assumptions. Right? So with this point, we want to plot the Z prediction on X and then the Z residual on Y. Prediction to X, residual to Y. Hit it that it should give you a histogram there. And then if you wish, normal probability plot can follow. You can produce all partial plots if you wish. And then you click on your continue. Then you click on your OK. Fatima, are you there? Fatima.
Yes.
Hope you are not sleeping.
No.
How many percent do you have?
29.
Okay. That means it will take you to 9 o'clock.
Yes, possibly.
Okay. All right. Our residual statistics is out, as you can see, and then the plot regarding that is being displayed. Have in mind, we're asked to compare using multiple linear regression, what factor predicts the loan amount? What factor predicts loan amount? And then we needed to lay our hands on the errors that may actually happen, so that we could now actualize the accurate factors. Have in mind, we will still show we will still bounce back to our p-value of 0.05, even when our variance can give us a clue to that. Now, the histogram is here. Regression standardized residuals is what you can see. These are the maps or the plots. After these are scatter plots. Scatter plot for loan amount. Scatter plot for loan term regarding loan amount regarding the loan term, and then loan amount regarding debt to DTI, and then loan amount in regards to interest rates. These are the partial regression, and then loan amount in regards to credit score. In fact, the expected outcome here and the observed is that everything was just a linear flow. So that means loan amounts let's even check the statistic, the predicted value, in case we may need to have. Okay, there's a standard deviation of 1, and the standard residuals is 0.75. That is good. Now the dependent value is our loan amount, meaning that loan amount actually will as correlate positively with all these informations as we can see here. Now let's come down to this table of Cohenity diagnostics, right? These are their variances. These are the constant we have, the monthly income, the savings, and all that. I'm looking for the significant value, so that we can use that to pick what we are actually looking at. All right, so this is the coefficient table. So from now, we can now see even tolerances here. So coming here, you can see my mouse very well. I am at the significant value column for each of this information using the dependent variable of loan amount. Now we have monthly income is highly significant to loan amount. You can see is less than 0.05. So here is 0.01. So monthly income is highly significant to loan amounts. And then with that, we can now say what factor predicts loan amount is the monthly income. That is the conclusion. The factor that predicts the loan amount is monthly income. Right?
So what if we have two factors below that 0.05?
Yes, those are the two factors you still state, or you use the two factors to predict the loan amount. Those are the two factors you still use. Now, imagine, just look at something now, sir. Since you just bring that up, let me just drag you further. This factor, monthly income, is acceptable, but look at the tolerance. Look at the tolerance is 0.42. So anyhow you want to use, if you change this to percentage, though it is this, but you must use this percentage so that you will not cross your boundary in giving highest amount when it is not required. Now, even say the upper bound is 4.0. That means it's the same 0.42, or if you want to give 42%, or 42% of the total monthly income that you can recommend for him or her, so that you won't be, under any stress or under risk region or distress region, right? So these are few informations that one need to consider, and then come up with his own, acceptability. Let's look at, let's predict if a customer will default. Let's just look at that let's come to analysis again, pick regression, and then go to binary logistics. Will this customer will this customer default in paying his loan or his debt? Just drag default risks into dependent. Pick default risks, take it to dependent, and then pick up all these informations. Let's even start with age. Bring age into covariate. Let's bring their monthly income. Let's look at the credit score. Let's look at the debt itself. Let's look at the loan amount, whether it will affect the customer not to pay. I'm even thinking of bringing out the term. How long will that affect the customer not to pay? Let's even consider DTI as well. All right. Hope the interest is here. Will the interest make the customer not to pay on time? Let's just consider that. What will predict that the customer will pay our money on time? Let's see. Let's check the options we have. Let's look at some plots there. You can go with classification plot. Correlation estimate. Let's see that. Activates confidence interval. Let it be at each step. Classification cutoff. Okay, we're good with that. And then everything is okay by me. Let me look at category. What is here? Let's go with this goodness of fit. Try to give us the very possible classification logistically on this understanding. Let's go with it. Holmes Lemon show goodness of fit. I just hope this will just give us something interesting. Let's click on OK. Wow, you're shouting for us. A dependent variable has more than 2 non-missing values. For regression, for logistic regression, the dependent value must assume exactly 2 values on the case being processed. Let me see what we could do. Has more than 2 non-missing. Let me see. Regression. Default rates. What is there on that default rates? Default rates is low, medium, and high. But this one should have given us what we are looking for. Not as a problem. Well, I'll figure this out, and then we'll still come back to do this analysis. We'll still come back to this analysis. But nevertheless, let's look at classify. Because I need analysis. Those are analyses that you need to determine if a customer will pay up our loan or will not. So cluster analysis is to segment customers into groups. Very simple. Where our customers just split this in monthly in big groups. Okay, label them by this. Iterate and classify. I hope that should be okay by me. Okay, 10 is enough. Options. Continue. Okay. All right, so this just classify them into low rates, and then the cluster as is being required. All right. So the final cluster for the income in regards to gender, number of cases in each cluster, and it's not telling us that the F-test should be used only for descriptive purposes because the cluster have been chosen to maximize the differences among cases in different clusters. This is just to cluster them. There's nothing much here, just to see you group customers into their clusters, and then nothing much here as it were. Let's look at this. Let me see if you can do this decision tree, and then we look at time series. I hope we can expand the more on something else. By God's grace, we can hit it for the last time. We need to bring out another data set that's more than this and run through more analysis to see more insights that SPSS can give as regards data analysis. Okay, decision tree, come down straight for analysis, come down to classify and pick your tree. This is still categorizing stuffs. This is still under categorizing customers. So push up your default to depend. Push your default to dependent. Push default there. Then pick up your age, income, score, and then just put into predictors. Just pick all of them there into independent. Let's start with age and then income. Let's look at debt. Let's look at DTI. Let's still consider loan amounts. Then let me see validation here. Okay, everything is okay by me. 3. Okay. 3 in a table format. Let's see the normal tree first. If the normal tree is okay by us, then we'll go with that. Okay, this is a summary of the tree. It has a maximum of tree depth of 3. That means it was able to break down the tree into 3 segments, and then the maximum is just 3 depths, and then the minimum cases of child is there just 50. However, these are the tree display based on its own classification. So it can classify them, as you can see, it has classified them into 1, 2, 3, 4, 5. 5 predicted rules, but all of them are just given 0, 0, 0. Let me just look at time series here. Think we have any time? Do we have any time information? Don't think we have time information in this data. Don't think we have any dates information. Okay. Let's look at loan term. Let's just put loan term here. Monthly debt, loan amount, under loan term, and then let's look at employment that will run through, and then this. Let's go. Okay, so this is just time series. It's trying to show us some information regarding the time, how which we have dates. This could have given us a very nice time display and payment of regarding monthly income, and then loan amounts given. Whereas assuming we choose other indices, it could have also display alongside. But the basic here is the loan term that we use. We have the list was the 36, and then we have 48, 36 to 60, 36 to 60, 36 to 60 a loan term. I mean, the list was 36 months, the apex was 60 months. All right. So these are being what we can easily find with these data sets, and then few of the questions we were able to get via analysis, right? I really wanted us to do that binary logistics. I really wanted us to get that done. This regression, binary logistics, I really needed us to get that done. Let me just look at this first. Let me use another value there. Let me see if this can work. Dependent here. Credits. Let's see this few. If this few can work. Goodness of it is there. Let me remove this correlation estimate. Okay. Wow. Okay. This works. This is good. All right. This works, right? Okay. Thank God this works. So we actually were looking at among these indices, which of them will be able to pay back our money as at when we need them. That is when we needed to bring in binary logistics, predicting if a customer will pay us back or will not pay us back. Right? So we had to bring this into play. And then, as you can see, we have the classification of the table. Repayment status. Normally, defaulted people are still 7 and 13. Then coming down to variables of the equation, significant value is seriously high. This is 0.187, meaning that it's higher than 0.05. That means there is no iota of significance or relationship that this customer will pay us our money as I'm going to. Right? When it comes to, but as you can see, we have debt here, but I didn't even put the category of customers. I could have put educational level so that we will have customers from educational level or perhaps income that can give us an insight if this set of people can give us our money when as at when due. All right, so debt significant value is 0.01, which is very strong. We have credit score, debt to DTI, and even long term are correlating very powerfully, meaning that the chi-square are not computed because of the redundancies. Now, they have a lot of redundancies. That's why chi-square is not really working. The residuals chi-square is not actually done because almost all of them, even this guy, 0.14, is also below 0.05. So all of them are actually, accepted in those understanding. Now let's look at test of model coefficients. All of them too also make up the significant value. As you can see, all of them makes up the significant value. And then Homans and Lomesh test, the significance is 1.0. Now we need to know what is their p-value. If it is 1.0 and then the chi-square is 0.000, what is their p-value? And even their degree is 5. What is their, test decision value before we can ascertain what this connotes? All right, so contingency table is being displayed here from their observed, both for those that will pay us and for those that will not pay us. And then they observe that I need to know what these steps are, right? So that we could now know what and what we are referring to. Okay. Which I put income or perhaps employment, so that we could know how and who we are referring to. But nevertheless, I believe with this now, this is 922. With this now, we have really touched a lot on these data sets. And by tomorrow, we need we'll get another data set so that we can now expand on some of these nitty-gritties that are here. There are some information here, or maybe some indices there that we need to explore, so that will not just be seeing values. We'll be seeing maybe some charts that can be interpreted into what a layman can understand, and then you can connote it, relate it to the deciding authorities based on what you have captured, right? So at this moment, I don't know, Fatima, if you're still with me, I don't know. I know that you may have a lot of questions, and I know one of your questions might be, how do you know where and what to put in any of those boxes? I will relate that to you.
Mm-hmm.
Yes, so that you use that to learn. And in fact, once we have another data set, we'll see what and what do you put or do you drag into any of these variable boxes, and why do you drag them there, and how do we know what to drag into those boxes, and what are the expected results that we should expect, and then as well as their interpretations, right? Mr. Joseph, I know you may have, I don't know whether you have any question as regards what we have done so far. But nevertheless, I will look for another data set that will explain more, and then we'll have more insights. At least if we could do twice of what is expected on a thing, you really get the knowledge out of that. Mr. Joseph, do you have any questions so far before we call it a night?
No, sir.
Okay. Although tomorrow is Saturday, so we'll be logging online for the continuity.
Okay.
And then Sunday, by God's grace, we should be launching straight into Tableau. Sunday, we it should be the same time. Or perhaps we can reduce it if there will be any reason for rescheduling, so that we'll not close late on Saturday. Then you'll be communicated as well.
Okay, all right.
But nevertheless, what time are you looking at, Mr. Joseph, for tomorrow as weekend?
I'm cool with any time, so
Is it?
I'm cool with any time.
Okay, you can go with any time. Fatima, do you have any time for weekends?
I'm just thinking we could do. Okay, same time is okay because I'll be attending cell meeting.
Okay. After cell meeting then.
Yes.
All right. Thank you very much for your time.
Thank you.
By
Well
God's
done.
grace, we will really enjoy. I know a lot of analysts doesn't really like SPSS that much. It's Python they do like. I believe once you enter into Jupyter Notebook, you really enjoy to becoming a data analyst. Then again,
Amen.
you enjoy data analyst when it comes to. Although you need to learn how to code a little, you need to learn a little, or which that will take a long time, but we'll see how to bring you up to speed
Okay.
based on what we have acquired. Thank you. Have a nice night, and then we'll meet
Thank you
tomorrow
so much.
by God's grace. Have a nice
Thank
night.
you.
Good night.
Well done.